Hello, everybody. So I wanted to make a little tutorial here, or really a short video that addresses something about tutorials. Today is the last day of the semester, well, lectures and everything already ended. All the students' homework is due this evening, so I am spending the day sitting right beside a computer so that I can jump on a Zoom call in a split second if anybody has any questions. And to pass some of the time, I was watching some tutorials. And I just watched this one a few moments ago. Thought these were some kind of nice looking waves. Uh, Procedural nodes in Blender. Uh, I did check before making this, and it had something that I sometimes feel is a bit of a problem with YouTube tutorials. When I did a search with some keywords from the names, saw at least a dozen. I stopped scrolling pretty quick, but at least a dozen tutorials that showed the exact same thing. And clicking around at different points in time, it was that thing where it looked like the people that make YouTube tutorials were all somebody made one, and then everybody else that makes YouTube tutorials about the same thing watched that tutorial and remade their own. And for procedural stuff in Blender, they just went over to the geometry nodes and were saying, okay, place this node here, place this node here, type this number in this box, and um, saying what to do, but not explaining how to get to it. Uh, like, for example, let me open something I can write on. Uh, journal. I guess that's how I pronounce this. It's like journal, but with an X. Nice little writing thing to use my pen. So when I watched that, I knew that it was just setting up some X, Y, and Z coordinates. And our Y was just coming along for the ride. We're going to go through all this, how to build this. And Z, well, it's a wave. So our Z is some amplitude value times the cosine of a scalar multiple of, I'll use eta, that's going to be a noise thing, plus x minus t, which is pretty much exactly like we see a wave as we're taught in a typical physics class. Physics 1, Physics 2, somewhere around that level. And our x value, to make it more interesting, we're breaking up the x value by curling things around, making the front of the wave a sine of the same thing. So some scalar multiple of eta, which is going to represent noise, plus x minus t. And then we'll add to that our cosine wave that is representing the up and down. C times eta plus x minus t. So I was able to watch the tutorial and know that this is what they were showing. The exact same thing I learned about waves in um, several physics classes. Whatever one they first show up in, I think waves first show up in Physics 1. It might be Physics 2. I had a lot of physics classes, and my graduate work was in mathematics. So knowing that this represents an interesting wave, how do we get from this to this? Or, in our modern world, seeing a YouTube tutorial where they're saying do this and do this, put this node here, type this number in this value box, and all of that stuff. How do we get back to an equation so that we can make it our own thing? I wanted to make a tutorial about that. So how do we get these equations to build the wave of and sort of understand this procedural stuff so that also we can build it from scratch instead of just following along a tutorial. So let's open up a new Blender file and go through that. So I'll open up a new general one, hit A to select all those, clear out the earlier stuff, and we can get started making our wave here. Well, obviously the first thing we're going to need is some sort of mesh to work with. So I'll come up to add a new plane. That'll work. If we go in edit mode, we can see that, well, a plane is just 4 vertices in space with some edges connecting them and then fill in the polygon. Not much to work in details there. So come back to object mode. I'm going to come over to modifiers and add in a subdivision modifier. Probably a simple one. We just need some spaces to work with. 5 probably be good. Maybe a little more. I think the tutorial I saw earlier used 7, so I'll just stick with that. There's some advanced features if you want to use those. The quality of it, turn that up and down. Use limits. It's a little bit quicker if we remove that part and just let it go with what it is. You can adjust that, but basically just get us um, enough material in that mesh to work with, enough vertices. So if I apply that modifier and come back to edit mode, we can see now there's lots of vertices and lots of little faces making up that face. So we can add some detail in now. I'm to object mode, and to make a nice moving wave, that's going to be some procedural operations. So I'm going to come over to the shading tab. Let's see, I'll move this up. We're going to be adding nodes, so probably need more space down below than up top. And first thing we want to do, by default, it goes to the shader node, shader editor, so that's our color nodes, color and normal displacements and stuff. So I want to actually change the geometry, so I'm going to go in geometry node editor and add a new one. So right now we just have the input of that plane feeding straight into the output. We need to make some more interesting stuff happen there, which we can do by setting the position, or setting the offset of the position. So I'm going to push Shift A to get to the add menu. You can go to the add here and search for stuff, but if you Shift A pulls up the add menu, and then you can see up here, then S will search. We do that a lot. So Shift A S to get to a search. And if we search for set position, we get this little node, and we can just bring it right in between those and click, and that'll go ahead and hook up on that wire. So now our plane feeds into this geometry, which feeds to the output, but we can make some adjustments to the offset of it. So I guess I'll jump over here to journal. This is going to be our ending result. So let me open a new page here. So I know I'll do Z first. And I know from math class that a couple good ways to get waves are either going to be sine of x or cosine of x. Sine starts in the middle, goes up, down, like that. Cosine starts at the top, goes down, and up like that. And I'm thinking this up part over here will make a nice crashing effect. That'll be better for crashing than a spot in the middle. So first off, we know we want Z to be some sort of cosine of X function. Cosine of X. I'll leave some space in there and we'll fill some things in. So first, that's what we need to set up first. So I'll do Shift A to search, and then S to search for position. So if you're new to Blender nodes, the get position is just position, and the set position is has set in there. So the get is implied. Then we can drag out from there, and that gets us right back to a search bar. So from that, if we separate our XYZ, that gives us a way to grab our X position, or like was written here, Z is a function of the cosine of X. So, let's just add that in. Drag out our X and search for math, which cosine's on there somewhere. I usually just hit add, just choose the top math option, and then choose cosine from this option. So cosine, and then we can feed that into our Z offset. Is that the one I want? Yeah, that worked. So we can see now that depending on our X position, I should look from the negative Y. That would, negative Y is considered forward. So X is increasing to our right, Z is increasing up, kind of the way we're used to looking at it in math class. So depending on where we're at in X, we get a different Z cosine position. Probably want some scale factors in here. So Let me spread things out. Grab those two, move them over, um, and Shift A, S, and search for math again. And we'll add a math right in here between them, and this time make it multiply. So we'll have some scalar multiple. You can see that's making it really big or really out front. And if we do the same thing over here, Shift A, S, search for math, and stick that in between those two, and again, switch it to multiply. Then we have, we're scaling up and down this way. So maybe 5 will work. Scale it up and down that way. And over in our equation now, that's going to be a scale factor on x. See, and then we have the amplitude here. And this is hopefully enough to see how to read these and translate to the traditional mathematical notation like you would have learned in a physics class. Or if you wanted to write this in code instead of the visual nodes in Blender, the way that it would look in code. I guess if we're writing in code, we need all the multiplication parts. A times cosine of C times X. So the offset is, I think I just wanted a Z offset. I'm going to add something else in there. That X one looked pretty good, but I'm going to do something different. So let me add another math one in here, or not a math. Search for combine. There we go. I skipped that step earlier. Let's grab all these, move it over just a little, and stick that back in there on the Z. There we go. So Z is a function of the amplitude of cosine of a scale factor on X. You see how that's just reading backwards to get to the traditional math notation. So that's how we build these things up. And that gives us a basic wave with the scale factors, so we can change it, add more waves, less, or adjust the amplitude up and down. Can these be renamed? No, some tags in there would be really nice, because then we could label what each one is to keep better track of it. That'll work for now. I guess the next thing is probably want to move this. So to move it, I think I'll write it down first and then do the procedural thing, because this video was trying to show that part. So I remember from physics class that to move a wave, we add or subtract time. So I'm going to subtract time, then add in some parentheses. So a scalar multiple of x minus time, so that our wave changes as time progresses. And to do that here, we can just, well, we're subtracting x minus time, we can just add another math node in. Shift A, S, search for math. The default's add. I'll just click it there to add in there. And for our value on time, we can type hash FRAME as our frame rate. And then we want to divide by something, because Blender has a pretty quick frame rate. So I did hashtag frame divided by 35. And that'll pull right off of our frame. So if we hit the space bar so it starts moving, then we have X. Well, I guess it's plus T now. If we look from the negative direction, what does subtract do? I wrote X minus T. Okay, yeah, so now it looks like they're moving this way. So I'll go with that. Moving in the wave appears to be moving in the positive direction. So just like we see in math class or physics classes, X minus T moves us in the positive direction. Give that a scale factor for how many ups and downs we get. Feed that into the cosine, and then multiply by the amplitude. Then we can do some more stuff for as far as procedural nodes. to make it look nice. Um, I guess the first thing to fix up might be that it's a nice smooth cosine wave. So to make it more interesting, we can adjust the x value, which would be the like the front surface of the wave, by using another wave. So I'm going to take the cosine and multiply it from there, hit Control C to copy, and then Control V, paste that in. And I'll take x, feed in there. I'm going to make this one a sine wave. And then this will give us a new x value, which you can see gives us a smooth curve. As we bring that up, uh, our x and sine, it kind of changes the shape of the wave. And to make it start to curve forward, what we really want to do is I'll go write it down. Um, Going back to what I know from math class, or really from a physics class, if we take our x to make it curved, maybe I'll add some little serifs on there, so like the capital X, uh, we can take some multiple of the sine of all of this stuff. I'm just going to write, I'll write a psi for now, which is going to be the same as this stuff, and then add to that some multiple of the cosine of the same stuff. Then we'll get our up and down wave from this part, and then this part gives us half of a circle. So when we add those together, our waves should start to look more like that. So we jump back over here and come out of the cosine, search for math, and I want to make this multiply because it's a scale factor, and then come out of here and look for math and add. Definitely ran out of room. I'll get that organized in a second. We want to add, let me put this on the bottom and add both of those, and then that will become our x coordinates. Let me try to make some room here. Move those over, then this up there. There we go. So you can see from the shape of the wave that gets it I guess leaning forward is what that does. As we scale up and down the sine wave, we get different curvature. That looks like a good start to the shape of the wave. So that gets us up to this point. Z is a cosine of x minus time, and then x is some multiple of some amplitude value on the sine of that same number, plus an amplitude on the cosine of that number, and that gives us a nice curvature on a wave. Hopefully you see here how we get from the traditional math notation to this. It reads backwards on our procedures. So z is a function of the amplitude of the cosine of a multiple of x minus time. And we're reading it backwards to build up that procedure. So that gets us a start. It's awful smooth though. You might want to adjust this. So we can make some adjustments by adding in some noise. I'll come over here and add noise. So to get our noise, I'll kind of do the same thing. I'll base it off the position, only I won't separate it this time. So Shift A, S, search for position, and then feed position into the vector component of a noise texture. And from the frac side of that, if we search for math and add, oh, that didn't feed in there the way I put that in the middle, we'll add the frac to that. So over here in our notes, this should match some of what we've seen before. I'll use psi, that looks a little bit cleaner there. So say psi is we have some scalar factor on, I'll use eta for the noise, kind of looks like an N, plus our x component minus our time. So we take that function of x and then take the cosine of that to get z, which I guess I can just write here. Z is some scalar value on the cosine of that wave function. And x, our final x component, is going to be the sine of that wave function plus the cosine of that wave function, with a couple amplitude values thrown in there for good measure. That way it's not really small. And you can see now we're really starting to get some something that looks more like waves, and we can start making adjustments to clean it up. If we turn our scale way down so it's not so much and we start to look like waves again, maybe bring up the detail. There we go. That's looking a little bit better. We could add more things. This tutorial's up to 21 minutes, so I'm going to stop there. We could bring the noise over and impact the cosine from that. But that kind of covered the spot I wanted to look at. So we write our final one out here. Let's see, what do we have? So our final x position, which I'll use serifs. So our final x position is going to be some scale factor on the sine of a multiple of our random noise pattern plus x minus t, so it moves with time. And then we'll add to that some amplitude on the cosine of the scale factor, well, same thing, our noise pattern plus x, I'll make that n longer so it looks like an 8, make sure it looks like an eta, minus time. Our y, our final y, we're not changing it, so y just comes along for the ride. And our z, I'll add some little serifs at the end there, is going to be the amplitude on the cosine of all those values like we would have seen in a physics class. C times eta, which can be our random noise texture, plus the particular x component, minus our time so that it moves forward. And that is the final wave. So also, if we wanted to write it in code instead of doing it this, we would also need the math class formula. So I just wanted to make that tutorial. It looks like we're coming on 25 minutes. Then we can just add some color to it. All right, we add some color, but that gives us a nice little texture on the wave. And hopefully that made sense how we build that up from like how we would have seen waves described in a physics class. I think they show up in physics 1. It might be physics 2. Wherever those show up, or maybe in some of your math classes. To take that and turn that into the procedural nodes in Blender, or if you wanted to explicitly write it in code, right, instead of that, jump over to the Python scripting one and just write up a bunch of Python code to do the same thing, you would probably need it in that math class, in something closer to the math class syntax. Hopefully that made sense and helped. I just felt like that was missing from the tutorials I was watching this afternoon on the procedural nodes. I knew exactly what they were doing, but when I searched, it was that thing that sometimes seems like a downfall on tutorials where all the people that make YouTube tutorials are just watching each other's tutorials and doing the exact same thing. And whoever made the original one didn't explain how we get to all of this. How do we figure this out if it's not um, without the instructions of place this node here and type this value in this particular node? And um, hopefully you found that helpful or interesting. I just thought I would share in case other people are ever curious about the same thing, how we build that stuff from scratch without just looking at a tutorial for it. Thank you.